Okay, so here's our continued fraction calculator, and it lets you write continued fractions that are of the form some integer, in this case 5, plus the square root of 13 over 6. We just want to do the square root of 5, so we're going to say 0 plus the square root of 5 divided by?
Divided by then just 1.
1. Very good. And then it tells us over here that the continued fraction, actually it told us down below here, sorry for moving the camera around, the continued fraction is this 2 plus 4 bar means 2 plus 1 over 4 plus 1 over 4 plus 1 over 4 plus 1 over 4 forever.
Cool.
And now what we can do is press a button over here where it says show convergence. See that button?
Cool.
And it shows us what the fractions are down here, but it was a little too fast for us, so let me scroll up a little bit. 2 is the first one that we saw, that's 2 over 1. Okay, 9 over 4. What is 9 squared?
9 squared is 81.
What's 4 squared?
It's 16.
So is 81 over 16 close to 5? Sorry for bumping the camera and knocking the focus away. Is 81 over 16 close to 5? What is 5 times 16?
5 times 16 is 80, so it's really close.
It's really close to 5. The next one, the next approximation is 38 over 17. Now I have to tell you, I don't know what 38 squared is, and I do know what 17 squared is though.
It's 189.
It's 189. So why don't we go quickly to Wolfram alpha.
Should open any tab.
What were those numbers? Was it 38 over 17?
38 over 17.
38 over 17. So let's ask Wolfram alpha. Can you move the camera over to see Wolfram alpha? 38 divided by 17 squared. Have I got it here?
Does that look?
Here it is.
1444.
Wow, 38 squared is pretty cool. I didn't know that. 1444 over 289. And look what Wolfram alpha says that is.
4.99653.
So that's really close to 5.
Maybe we should memorize 1444 over 289.
If you ever need to do the square root of 5, well, sorry, if you ever need to do the square root of 5, 38 over 17 looks like a pretty good approximation.
Yeah.
Because 1444 over 289 is almost 5. And I bet 289 times 5 is 1445. Let's check. 289 times 5 is 1445. It's just 1 away.
Wow.
And since we're goofing with Wolfram alpha, let's check the next one. 161 over 72.
I don't know any of those.
Do you know 161 squared?
No.
Do you know 72 squared? All right, well, let's go back to Wolfram alpha. Eek. 161 divided by 72, and we'll square that. Okay?
We got
25,921 divided by 5184. And look what that is. 5.0001. So it's a little bit too big. So 25921 over 5184 is a little bit bigger than 5. What would you guess 5184 times 5 is?
It's probably 25920.
Oh, let's see. Can you tilt the camera up here?
Okay.
5184 times 5 is 25920.
Cool.
How about that? How about that?
We can get really good approximations of square root of 5.
We can get really good approximations for square roots this way. And as you pointed out, we can learn that a number is irrational if its continued fraction goes on forever, because these fractions that we saw over here will just keep going on. Sorry for the focus problem. Will just keep going on forever. The last one they wanted to show us before the ... was this crazy one.
299537829 squared.
Yeah, over
133975148. It's around 2.23.
Yeah, it's pretty amazing, right?
Yeah.
All right, good job. Good job.